Hello, this is Dr. Lukes. We are looking at Chapter 18, Multi-Loop and Multivariable Control. And in this video lesson, we're going to be beginning to look at actually how you would control a system like this, what that control system, those loops might look like. These are two ways that we might control a system with two inputs and two outputs. So my inputs, U1 and U2, my outputs, Y1 and Y2, are here. And if we look at these, I have for U1, it goes through the process and becomes the output, but I have a control loop on this now. So I'm measuring this, and we are, for simplicity, leaving out the measurement and the valve. We're measuring, comparing to the set point to calculate an error, sending it through the controller, which is changing, using a valve, the output or the flow rate through U1. Okay? But this is also an input to process 2 for output variable Y2. So we also have this. In the meantime, Y1 was not just a result of U1, it also had effects from variable U2 that goes through its own transfer function, is added to the U1 and its transfer function before you calculate U. So I have U1 affecting both Y1 and Y2, and I have U2 affecting both Y1 and Y2. But I'm only controlling each valve with one controller each. Okay? All right, so this is what is called a 1-2 pairing. Okay? So 1 is being paired with 1 as a primary control loop. 2 is being controlled with 2 using that as the primary. But we also do have input modifications due to the other variables. But my valve is controlling the part that is affecting output U1 affecting Y1 and U2 affecting Y2. On the other hand, if I have a 1-2 or a 2-1 controller pairing, it's going to be kind of the same thing, but my controller this time is U1 is going through and affecting Y1 and Y2. I'm measuring Y2 this time, comparing to the set point, and making the changes based on process 2 for my primary loop on this. On the other hand, U2, I am going through the process, measuring, comparing to the set point, sending it to the controller, and then again going through this loop. So my primary loop is a little bit odd shaped. Okay. So that's the 1-2 and the 2-1 pairing. Now, obviously, you could just switch the names, the nomenclature of these, but the point is we actually don't know which variable we should be pairing with the other variable. When we have these process interactions, right, U1 affects both Y1 and Y2, those interactions might create some undesirable interactions between the control loops. It may make changes that you didn't expect. Okay, so we have control loops interactions that are due to the presence of a third feedback loop. Now, I only showed you 2 loops there, but there is, in fact, a third loop. Let's look at that in a moment. But let me just tell you that what's going to happen is because of these control loop interactions, the closed loop system, once I turn the control on, it actually may be destabilized. So I had something that was working separately, but now does not work. And the controller tuning is definitely more difficult. If you look at the block diagram analysis, it depends on whether you have all the loops turned on or some of the loops turned off. They go through the details of the block diagram algebra, but I don't think this is impossible for you to just figure out on your own, but you can read in the book to get this better. So y1 over u1 for, this is the 1, 1, 2, 2 pairing. So u1, y1, it goes through gp1, 2, okay? That should be a 1, 1. That is a 1, 1. It's just my slides are not very clear to read. Sorry about that. So GP11 is going to be what I end up with there if the loop is open. Okay, Y1 over U1 with it closed passes through this loop. Okay, and so therefore it also has this part about GP12, okay, GC2, P21, okay, so it goes through this loop, okay, and then because that passed through the loop, it's over 1 plus the product in the loop, GC2, GP22. Okay, and again, they do the details of this in the book. I'm not overly concerned about that at this stage for us. Now, I keep referring to this hidden control loop, and when I drew those loops, they were crazy. Now, we look at this and think, okay, there's a control loop here, and there's a control loop here. But the point is that if I look at this output Y1, there's also, besides just this control loop, there's also this crazy loop all going in the forward direction, so therefore it is a loop. And it included U1, U2, Y1, Y2. All of them are interconnected. And so it's that hidden feedback loop, the one that you get when you take the loop, okay, you started with this track, and you follow it through, but now then go the other way. And indeed, you end up back where you started. That's a loop. Okay, so we're doing all this so that we can get to a characteristic equation. Again, if you'll just trust what I'm doing here as far as it is in the math, what you end up with is 1 plus GC1GP11. Okay, so the controller 1 and the process, so this is U1 with its controller going to Y1. And 1 plus GC2GP22. So this is U2 being paired with Y2 and the U2 control valve. Okay. And then minus the controller for U1 times the controller for U2 times GP12, GP21. And this is where that little secret inner loop comes in and gets us. And so we end up with this equal to 0. This is our characteristic equation. Okay. Now, if I happen to have either GP12 equal to 0 or GP21 equal to 0, what happens here? Well, I end up with just 1 plus GC1GP11 times 1 plus GC2GP22 minus 0 is equal to 0. And I know how to solve something where two things are multiplied together. 1 plus GC1GP11 equals 0, or 1 plus GC2GP22 equals to 0. In other words, I have decoupled the interactions. U1 affects Y1, not Y2. U2 affects Y2 and not Y1. Okay? But I have to have either any one of those 0 to decouple them. If not, this top equation is going to be our characteristic equation. So we'll pause there. We're going to come back and we're going to look at what I can do to analyze and make decisions about my control system design.